Hello viewers, Wagadarunal taking you through the story of Olevel mathematics, and this video I'm going to go through the topic of transformational geometry. So this video is suitable for students in both senior 3 and senior 4. So before we start, let's first look at the course outline. So senior 2 math topics, these are the topics, they are 11. Senior 3 they are also 11, and senior 4 they are 6. So what is ticked is what is available on this platform so far. For example, if you want senior 2 math topics, at the end of this video there will be an end screen which will be like this. So if you want all the videos in senior 2, just double click on this. At the end of this video you'll be able to, it will take you to the folder for senior 2 topics. And if you want for senior 3, you just double click on this. But it will happen at the end of the video. So in this video we are going to talk about this topic of transformational geometry. So transformation is the change in position, size or shape of a figure, of a given figure, called an object. So that figure is called an object, and what results after is what we call an image. So we shall come and say that the result of this change gives another figure called an image. So object is the original figure and image is the figure which results after transformation. So any points, lines, angles or any other features which do not change in the transformation, these are given a special name called invariant. So this word will be used frequently in this video. Now an object can undergo transformation in any of the following ways. So this topic of transformational geometry is subdivided into 6 parts. 1 is translation, 2 is transformation by matrix multiplication, 3 is combined transformation, that is more than one transformation, then 4 is reflection, 5 is rotation, and 6 is enlargement. So all these will be covered in this video in the order given here. There are some things we need to note is that a transformation which does not change the size or shape of an object is called an isometry. For example, translation, reflection and rotation, those are called isometries, and while enlargement is not an isometry. So if the shape and size of an object is the same as its image, we say that the object and the image are congruent. Another word for congruent is identical. That is when the shape and size does not change. So in the previous slide we saw the word invariant. Here we have seen the word congruent. Then if the position, size and shape, now in this second bullet it was only the shape and size which remains the same, but if also the position remains the same, that means that the position, size and shape of an object is the same as that of an image. We say that the object and the image are invariant. They do not change. So now we shall start with translation. So a translation is a transformation such that all the points in the object move through the same distance and in the same direction. Distance and direction. In order to obtain the image of a point under a translation, we add the vector of the translation to the position vector of the point. In other words, we use the formula that image point will be given by object point plus the translation. So you'll see how this formula is used in the example. So there's something we need to note is that movement to the right and movement upwards are defined as positive, while movement to the left and movement downwards are defined as negative. So when you say negative, it means that it is either to the left or downwards, and we shall see that when we represent this translation graphically. So now we shall go to question 1, which came from UNEB 2016 paper 1 question 5, and says an object at O, which is 0 0, undergoes a translation A, which is 5 negative 12, then followed by translation B, which is 3 6. Part A, find a translation equivalent to the two translations A and B. So the equivalent translation is good by adding the two. So we shall add A plus B to get the equivalent translation. Therefore A is here and B is here. When you add the two, you'll come up with this plus this, which is 8, this plus this, which is negative 6. And that is what they wanted. So part B, they said how far is the image from 0 0, which was the object. Therefore they want the distance between the object and the image. So to get it, you have to first get the position of the image. So image will be got by object plus the equivalent translation, which gives you that. The distance will be the magnitude. So magnitude of this will be 8 squared plus negative 6 squared, everything under square root, to come up with 10 units as the required distance. Then question 2 came from UNEB 2009 paper 2 question 6, and says a translation T maps A, which is negative 2 3, onto A prime, which is negative 16. Find the image B prime of B, which is 5 4, under the translation T. So the same translation here. Now here what we need to do is to first get this translation using this object and image. The good thing, we know the relationship that image is equal to object plus translation. Therefore when I make translation the subject, it will be image minus object. So this image here minus this object here will give you negative 4 7, and that will be the translation. Therefore now to get the image of B, I'll remember that image is equal to object plus translation. That I've got translation here and I have the object there. Therefore when I add the two, I'll come up with this as the position of B. Therefore in coordinate form it will be 1 11. Then question 3 came from UNEB 2005 paper 1 question 5, and says if the point P, which is 2 negative 1, undergoes a translation represented by matrix 11 4 negative 4, find the image of P. So you have the object and the translation. Therefore we can get the image from this relation. Object is there, translation is there. When I add the two, I'll come up with this as the position vector of the image. Therefore in coordinate form it will be 13 negative 5. So that was translation. Hope you have mastered the concept behind translation. Now we shall go to the second part, which is transformation by matrix multiplication. The good thing, the topic of matrices is already available on this platform under the folder for Senior 3. So matrices can be used to represent transformations. In the XY plane, we use a 2 by 2 matrix to represent a transformation. So here the matrix we are interested in will be a 2 by 2 matrix. This transformation matrix can be determined by calculations using the formula that image point is equal to transformation matrix multiplied by the object point. Now I think you remember under translation it was addition, but here we have to multiply, and the order matters. It has to be transformation matrix first, then object point next. The order matters. So let's see how that formula is used. So we'll start with question 1, which came from UNEB 2008 paper 2 question 10, and says 2 points A, which is 5 1, and B, which is 6 0, are given a transformation defined by the matrix this 3 1 1 0. Find the coordinates of their images. So like I said, we start with to get the image you have to say object multiplied by transformation multiplied by the image, by the object, to be able to come up with the object. So when I multiply, remember when you multiply row by column. So this row by column, meaning that 3 times 5 gives you 15, and 1 times 1 gives you 1. Then here also row by column, 1 by 5 gives you 5, and 0 by 1 gives you 0. So in the end you shall come up with this column matrix and encode by the side coordinates. So you have to say that the image of A is 6, 5. Then for the image of B, we shall do the same. Multiply by the matrix followed by the object. When I multiply, it will be row by column. So 3 times 6 gives you 18, and 1 times 0 gives you 0. Then here 1 times 6 gives you 6, and 0 times 0 gives you 0. So in the end, you shall come up with column matrix of 18, 6, and the coordinate form it will be 18, 6. So you have to remember to write your image in coordinate form. Then question 2 came from UNEB 2004, paper 2, question 5, and says the transformation described by the matrix this, which is 2bc3, maps the point this, which is negative 1, 3, onto the image of 10, 8. Find the values of B and C. Now here still we have to remember that image is equal to matrix of transformation multiplied by the object. Therefore this matrix multiplied by this object will give you this image. Then from there we shall multiply. So this times this gives you negative 2, and this times this gives you 3b. Then also this times this gives you negative c, and this times this gives you 9. So these are two column matrices and they are equal, so it implies that when I first take the first row, I'll come up with this. Therefore when I make B the subject, B will be 4. What about when I take the second row? When I take the second row, I'll come up with this. Therefore make C the subject and C will be positive 1. And that's what they wanted. Then question 3 came from UNEB 1997, paper 2, question 4, and says under the matrix transformation this, which is 1a, b, negative 4, point P, which is 3, negative 2, is mapped onto point P prime, which is negative 117. Find the values of A and B. So still we use the same procedure as in question 2. Matrix multiplied by the image, by the object, gives you the image. Therefore this times this gives you 3, and this times this gives you negative 2a. This times this gives you 3b, and this times this gives you positive 8. Therefore when I equate the two, the first row, I'll come up with this. My aim is to make A the subject and A will be 2. Then this, equating this to this, I'll come up with that. My aim is to make B the subject and B will be 3, and that's what they wanted. Then question 4 came from UNEB 1993, paper 2, question 7, and says the images of point I, which is 1, 0, and J, which is 0, 1, under a transformation represented by a 2 by 2 matrix are I prime, which is 2, 0, and J prime, which is 0, 3. Respectively. Determine the coordinates of K prime, which is the image of K with coordinates 1, 1 under the same transformation matrix. So we have to use these two pairs to get the matrix of transformation first. Then we shall come after the related matrix of transformation be A, B, C, D. Then we shall use the relation that matrix of transformation multiplied by the object gives you the image. Now the object and the image, they must correspond. This is A, this should be A prime. Then this is B. Okay, we have used I and J, so this is I, this should be I prime. This is J, this should be also J prime. So the order matters. The next is to multiply. So this with this gives you A, and this with this gives you 0. This with this gives you 0, and this with this gives you B. This with this gives you C, and this with this gives you 0. This with this gives you 0, and this with this gives you D. So therefore, you shall compare because they are equal. So this will be equal to this. That's why you see here A equal to 2. Then this will be equal to this. That's why you see here B equal to 0. And this will be equal to this. That's why you see C is equal to 0. And this will be equal to this. That's why you see D is equal to 3. Therefore, the transformation matrix will be A, B, C, D. So come and substitute for A, B, C, and D to come up with 2, 0, 0, 3. Now that you have got the transformation matrix, we can get the image of K. So using K, which is that, the image will be got by multiplying matrix followed by the object to come up with this as the image. But they want the coordinates, so you write it in coordinate format will be 2, 3. Then now we shall go to question 5, which came from UNEB 2005, paper 1, question 12b, and says a transformation maps 1, 2 on 2, negative 1, 4, and also 2, 3 on 2, negative 1, 7. So this is the object, this is the image, object, this is the image. Find the matrix of this transformation. So this one is the same procedure as we have done before. So we shall first select the matrix of transformation B, A, B, C, and D. Then we shall use the relation that matrix multiplied by the object, it gives you the image. So this is the object, this is the image, object, this is the image. The order matters. The next is to multiply. So this with this gives you A, and this with this gives you 2B. This with this gives you 2A, and this with this gives you 3B. This with this gives you C, and this with this gives you 2D. This with this gives you 2C, and this with this gives you 3D. That's how they multiply matrices. The next is to compare. So this will be equal to this. That's why you see here equation 1. Then also this will be equal to this to come up with equation 2. And this will be equal to this to come up with equation 3. And lastly, this will be equal to this to come up with equation 4. Now we have 4 equations and 4 unknowns. Therefore, you have to multiply them. Sorry, you have to solve them simultaneously. Let me start by equation 1 and equation 2. So multiplying 2 throughout this and subtracting equation 2 from it, I'll come up with this. So this cancels, though this and this gives you B, and this gives you negative 1. So you've got the value of B. Now from equation 1, I can substitute for B and be able to come up with the value of A as 1. So now I'll go to equation 3 and equation 4. So 2 multiplied throughout by equation 3 and subtracting equation 4 from it, I'll come up with that. Therefore, D will be equal to 1. Now, shall come and say that from equation 3, I'll come and substitute for D to come up with C as 2. So now I've got the values of A, B, and C. Therefore, the transformation matrix will be this, which is 1, negative 1, 2, 1. Now we shall go to the hence part. So for the hence part, the hence part said determine the image of 3, 0 under the transformation, under the same transformation which we have got. Remember, image is got by multiplying matrix with the object. Therefore, I'll come and multiply this matrix here with this object here to come up with the image here. In coordinate form, it will be this, and that's what they wanted. So that has been matrix transformation by matrix multiplication. Now we shall go to combined transformation matrices. So in previously we have been given one matrix and we have been using it to multiply with the object to get the image, but sometimes they can give you more than one matrix. In particular, they'll give you 2 matrices, and in this case they can tell you to either obtain the image of an object under combined transformation, or to obtain a single transformation matrix which is equivalent to the combined transformation matrices, or to obtain a single transformation matrix that would map the final image back onto the object. So all these ones will be covered under this part of combined matrices. So we shall start with this one, which is successive transformation, and this one, then we shall go to this, which is single matrix of successive transformations, and lastly we shall end with inverse of successive transformation under these combined transformation matrices. Now let's start with the first part of successive transformation. So here we shall say that an object can undergo several transformations, one after the other. This is done such that the image of the preceding transformation becomes the object of the next transformation. Always remember that. Therefore, suppose that an object A, point A, undergoes a transformation M followed by another transformation N. This means that the image point A prime under a transformation M becomes the object of the next transformation N, which forms a final image of A double prime. So in short, mathematically we shall say that image of A prime will be got by transformation matrix M multiplied by the original object point A. But the final image A double prime will be got by multiplying transformation matrix N followed by the object point, which is A prime. So what was image here becomes the object here there. So question 1 says matrices M, which is 0 1 negative 1 1, and N, which is 1 2 0 negative 1, are used to map the point A, which is 3 negative 2, onto A double prime. What are the coordinates of A double prime under the matrix of transformation M followed by N? So you shall come and say that for matrix M, you come and write this M multiplied by this object to come up with image A prime. So when I multiply this, I'll come up with this, and that will be the image of A double prime. Sorry, A prime. But they want A double prime, meaning that we also have to multiply this. This becomes the object to this transformation. Therefore, image of A double prime will be got by this matrix of transformation multiplied by this object to come up with this. Therefore, in coordinate form, it will be negative 12 5. Now we shall go to part B, which says that single matrix of successive transformation. So if each of the successive transformations has a matrix transformation, then a single matrix that represents all the transformations can be obtained. Such a matrix maps the original object onto the final the final image. Therefore, suppose that object A undergoes the transformation M followed by another transformation N. A single matrix that represents the transformation M followed by transformation N is written as NM. So note the order of this transformation which we are going to multiply. This one, the last one is what starts, and the first one is what ends. So this is very vital, it shouldn't confuse you. So if it is M followed by N, it is N you first write, then M comes last. In other words, we have said that the single matrix of M followed by N is given by NM. So the last becomes first and the first becomes last. If you remember that concept, then we shall go through these examples. So question 1 came from UNEB 1999, paper 1, question 6, and says matrices which is P, which is 0 1 negative 1 1, and Q, which is 1 2 0 negative 1, are used to map a point A, which is 3 negative 2, onto point A prime. What are the coordinates of A prime under the matrix transformation Q followed by P? So Q followed by P means that the matrix will be PQ, because we know that what is last comes first and what is first comes last. Therefore, we shall come and say that the single transformation matrix of Q followed by P is given by PQ. Therefore, come and write your P and write your Q, then multiply the two to come up with this matrix. And that will be the single matrix. Now, this matrix will map this object into the final image, which is A prime. Therefore, come and multiply this matrix with this object to come up with the image, and that will be the final image. In coordinate form, it will be 2, 3. Then question 2 came from UNEB 2011, paper 1, question 16, and says a rectangle ABCD has vertices A with the, which is that, B which is that, C which is that, and D which is that. Rectangle ABCD is mapped onto rectangle A prime, B prime, C prime, D prime by the transformation matrix 2, 0, 0, 2. Part A. Find the coordinates of A prime, B prime, C prime, D prime. I think let's start with part A. So part A, we shall say that this one, so the order matters. This is A, this is B, this is C, this is D, meaning that what will come here will be for A prime, and this will be B prime, and so on, C prime and D prime. So multiplying is row by column. So row by column gives you this value, then also this row by this column gives you that value, and do the same to get all these other values. Therefore, you come and conclude that A prime is this 2, 0, B prime is 6, 0, C prime is 6, 2, D prime is 2, 2. That was part A. So part B says rectangle A prime, B prime, C prime, D prime is mapped onto A double prime, B double prime, C double prime, D double prime, with vertices of A double prime that, B double prime that, C double prime that, and D double prime that. Find the matrix of transformation. So they have given you the object and the image, and they want the matrix of transformation. Therefore, you come here and write. So you come and say that let the matrix of transformation be A, B, C, D. So you have the object, which is this one, and the image was given, which is that. Therefore, the matrix will be this side. So remember, the order matters. It has to be transformation matrix multiplied by the object. So when I multiply, so this side will come up with this. I think by now you know how to multiply matrices. So next is to compare. For example, I can compare 2A with 2 to come up with A, which is 1. And I compare also, let me see here, 2C with 0 to come up with C, which is 0. And I can also compare this or this. I can compare this with this. The good thing I already know A, so I can get B. And I also compare this with this. And the good thing I know C, I can be able to get D. So let's do that in the next slide. So when I compare 2A will be equal to 2, therefore A is 1. And 2C is equal to 0, implying it is 0. Then 6A plus 2B is equal to 10, therefore substitute for A and be able to get the value of B as 2. Then do the same for D, so substitute for C to be able to get the value of D as 1. So now that I've got A, B, C, and D, I can get the transformation matrix, which will be that. Now I shall go to part C. Now part C says find a single transformation matrix which maps the rectangle ABCD onto A double prime, B double prime, C double prime, and D double prime. Now this one is somehow, this is now mapping the original object onto the final image. So how do we do that? So the required matrix, we come and say that the required matrix is the matrix of transformation this followed by this. Remember, we first use this to get the first image, then we use this to get the second image. Therefore, the required matrix will be, like I told you, the first becomes last and the last becomes first. So this last will become first and the first becomes last. Now when I apply the two, I'll come up with that, implying that the matrix is this, and that's what they wanted. Now shall go to inverse of transformation. So the inverse of a transformation reverses. Now that word reverses the transformation, i.e. it is the transformation which takes the image back onto the object. Now previously we saw a single matrix which maps the object onto the final image, but now here the inverse will map the image back onto the object. So suppose that an object point A undergoes a transformation M followed by another transformation N to map a final image A double prime. So a single matrix that represents the matrix M followed by N is written by this. I think you remember that the first becomes last and the last becomes first. Now that I've got that single matrix, I'll come and say that this means that this matrix NM maps the original object onto the final image. But when we bring in the inverse, it means that I want to get a matrix which maps the final image back onto the original object. Therefore, I'll come and say that the matrix that would map the final image back onto the original object will be the inverse of NM. So that is the use of the inverse. It helps us to map the image back onto the object. So then now let's go through these questions. So question 1 came from UNEB 2008, paper 1, question 15b, and says, given T, matrix T which is that, and matrix M which is that, find Roman 1 the image of points A which is this and B which is that under the transformation Tm. So here they are giving us the order of the matrix multiplication. So you come and say that Tm, first of all, Tm is what? T multiplied by M in that order to come up with this matrix. Therefore, the final image, the image will be that. So this is the object of A, object of B, and this will be the image of A, image of B. Therefore, come and write in coordinate form that A is that and B prime is that. So that was Roman 1. Roman 2 says, find the matrix of transformation which will map the images of A and B back to their original position. So it's mapping the image back onto the object, meaning that we need an inverse somewhere. So let's go through that solution and see in the next slide. So we shall come up with the matrix of transformation which will map the images this and this back onto their original position is the inverse of Tm. So I have to get the inverse. To get the inverse, I need the determinant. So determinant will be 0 minus -1, which is that, because it is product of major diagonal minus product of the minor diagonal. I think you remember that. So determinant is that, adjoint is that. Therefore, the inverse will be given by this. So this symbol denotes inverse of Tm. Then question 2 came from UNEB 2016, paper 1, question 16b, and says the image of ABCD under a matrix of transformation this is that A prime, B prime, C prime, D prime. The coordinates of the image are this. So that when you the coordinates of the image, so here there was D prime. Determine the coordinates of A, B, C, and D. So they have given you the image and the matrix of transformation, and they want you to get the object. So what we need to do, we have to get a matrix which will map the image back onto the object, and that will be the inverse. So to get the inverse, we have to first get the determinant. So this minus this gives you that. Therefore, the inverse will be given by that. So here, these one entries change, interchange, and these signs of this minor diagonal change. So here it was -2, it becomes +2. That is called the adjoint, then multiplied by the 1 over determinant to come up with this as the inverse matrix. So that means that this matrix will map the image back onto the object. Therefore, I multiply this inverse with the image to get the object, and this will be the coordinates of the object. Therefore, A is that, B is that, C is that, and D is that. Now shall go to question 3, which came from UNEB 2017 paper 1 question 16, and says a triangle whose vertices are P, Q, and R is mapped onto triangle whose vertices are this by a matrix of transformation this. The triangle P double prime Q double prime R double prime P prime Q prime R prime is mapped onto triangle P double prime Q double prime R double prime by a matrix of transformation this. Find Roman 1 the coordinates of P double prime Q double prime and R double prime. So here the good thing, we know this image. Now this image will act as the object for this transformation. Therefore, we can use this as the object and this as the transformation to get the image of this, which they want in part A. So let's first do that in the next slide. So this is the matrix and this is the object now, so we'll come up with this when you multiply. Therefore, the coordinates are these ones: P double prime, Q double prime, and R double prime. Now shall go to part B. So part B says find the single matrix of transformation which would map P double prime, Q double prime, R double prime back onto P, Q, R, or back onto the find original object. That means that there is an inverse which is needed somewhere. So what you're going to do, we are going to first get the single matrix of transformation. So this was the first one and this is the second one. Therefore, the single matrix which maps the origin final image back onto the object is the inverse of BA. Remember, the order of this matrix is that the last becomes first and the first becomes last. Therefore, we are going to come and first get that single matrix, which is BA, and to be this. I think remember this under matrix multiplication. Then the determinant of BA is 4. Therefore, the single matrix will be the inverse, which will be 1 over the determinant multiplied by the adjoint to give you this. So that was part B. Now we shall go to part C, where they want the coordinates of P, Q, and R. Now the good thing, we have got the matrix which maps this back onto this object. Therefore, when I multiply that matrix with this, I'll be able to get these coordinates of the object. So I'll come here and say that for part C, I'll get this matrix, inverse matrix, multiplied by the image to come up with the object. Therefore, I'll write them in coordinate form: P, Q, and R. Then we shall go to part D, which says the area and the determinant of a matrix. So there is some relationship between area of a given figure and the determinant of a matrix of transformation. Therefore, you come and say that under some transformations, the size, shape, and object of the objects do not change, while under other transformations, they change. When a matrix represents a transformation, the ratio of the area of image to the area of the object is equal to the magnitude, now that word magnitude, of the determinant of the matrix of transformation. Now magnitude means what is negative becomes positive. Remember, in the determinants, the determinant can either be positive or negative. So in cases where the determinant is negative, it implies that this word magnitude helps you to ignore the negative sign. And mathematically this is written as magnitude of determinant is equal to area of image over area of object. So let's see how this formula is used. So question 1 came from UNEB 2020, which is last year, paper 1, question 9, and says a rectangle whose area is 16 centimeters squared is given a transformation represented by matrix that 3, 6, 2, 5. Find the area of the image of the rectangle. So now that magnitude of determinant is equal to area of image over area of object. So magnitude of this determinant will be area of image, which is A, and over area of object, which is 16. Therefore determinant is this minus that, which is here. This magnitude sign, you first maintain them, then this one is maintained. Now this magnitude sign means that if you get a negative here, you ignore it and write a positive. So in this case, the good thing, it is already a positive, so I'll just remove them and come up with that. Make A the subject, and that will be the area of the image. Then question 2 came from UNEB 2019, paper 1, question 5, and says a square of area 36 centimeters squared is transformed to an image using matrix that. Determine the area of the image. So still we shall go through the same procedure. Code the formula, then substitute. Simplify. So this one determinant will be this minus that, which is that. Therefore simplify and make A the subject, and that will be the area they want. Then question 3 came from UNEB 2014, paper 1, question 9, and says an object P whose area 4 centimeters squared is transformed by matrix this to its image P prime. Find the area of the image, which is P prime. So still we shall go through the same procedure. Code the formula, substitute, then get this determinant, this minus that, to give you this. Then after that we shall make A the subject, and that will be the area of the image. So now we shall go to question 4, which came from UNEB 2001, paper 1, question 10, and says a triangle ABC whose area is 12 centimeters squared is mapped onto its image A prime, B prime, C prime by a transformation represented by matrix 2, 1, 3, 4. Find the area of A prime, B prime, C prime. So still we shall code the formula, then we substitute, all that we get the determinant, this minus that to give you this. Then simplify and then make A the subject, and that will be the area they want. Then question 5 came from UNEB 2018, paper 1, question 13, and says the vertices R, S, T of a triangle are mapped onto this R prime, S prime, and T prime by a transformation P, which is 1024. Part A. Find the coordinates of the vertices of the image triangle R prime, S prime, T prime. So let's first start with that. We already know that matrix multiplied by the object gives you the image. Therefore, you come here and say that matrix multiplied by this object gives you this image. So we already covered how to multiply matrices under the topic of matrices, and it's available on this platform. So that means that R prime is that, S prime is that, and T prime is that. So we have to remember to write in coordinate form. Then part B. So part B says use the determinant of P to find the ratio of the area of RST to area of R prime, S prime, T prime. So that means they want the ratio of object to image. So first of all, if you come and get the determinant, it will be 4. Now this determinant is the ratio of image to object, but remember they want object to image, therefore it will be the reciprocal, and that will be 1, 4, and that is what they wanted. Now we shall go to part C. So part C says, determine the matrix of transformation which maps the image back onto the object. That means there should be an inverse somewhere. So shall come and say that the good thing I already got the determinant as 4. Therefore, the inverse or the required matrix will be the inverse of P, which is 1 over determinant multiplied by the adjoint to give you that. So now we shall go to the third part, which is, the fourth part, which is reflection. Remember, we are going in order, so we have reflection, rotation, and enlargement. So reflection is part number 4. So reflection, for an object to be reflected, there must be a mirror line. So what is a mirror line? A mirror line is a line from where reflection of object takes place. And there are some general properties of reflection, and these include the following. 1. All points change positions except those on the mirror line. So points on the mirror line do not change position, but the rest of the points will change position. We shall see that under the worked examples. But let's see all the properties. So property number 2 says, the mirror line is the perpendicular bisector of the line joining any pair of corresponding object and image points. Also note that the perpendicular bisector, so sometimes they can give you the object and the image, and they tell you to get the mirror line, so they have to remember that you have to get a perpendicular bisector. We shall also see that in the worked examples. Then property number 3 says the object and its image are oppositely congruent. So I think you remember at the very beginning of this video we talked about this term. We talked about the term invariant, we talked about the term congruent, and the term isometry. I think you remember them. So here the object and the image are oppositely congruent. That is, the lengths and angle remain the same, but direction is reversed. Property number 4, the lengths are invariant, so that reflection is an isometry. So I think you remember what this term invariant and isometry means. They are talked about at the very beginning of the video. So with that, we shall go through some of the examples. So question 1 came from UNEB 2018, paper 1, question 8, and says a point A, which is 2, 5, is reflected in the line y equal to x, which is shown on the graph. So this is our point A, and this is our line. So this line is what we call the mirror line, so the line upon which reflection occurs. Then part A, use the graph to show A prime of A prime, which is the image of A. So remember, we would have drawn something like this together perpendicular, but sometimes it may confuse you because it may confuse you. So what we do, we shall first take direction to the left and also direction downwards to locate the final image. So what we do, when we take this direction, we shall count 1, 2, 3. So those are 3 steps. Therefore, even downwards, we shall count 3 steps. 1, 2, 3. So this will become the position of the image. So when you do that, that will be now A prime, but they told you to state the coordinates in part B. Therefore, you shall come and say that from the graph, the coordinates of A prime are 5, 2, 5, 2. And that's what they wanted. So that is how a mirror line works. But I'm going to look at more examples for you to grasp the concept. So question 2 came from UNEB 2011, paper 1, question 4, and says point A, which is 0, 3, is reflected in the line y plus x equal to 0. Find the coordinates of its image a prime. So here we shall need this. We shall need to get some 2 points, which we shall use to draw this line. So we have x and y coordinates. So if x is negative 5, put your negative 5 here, you'll come up with y as 5. So that will be 5. So negative 5 is one coordinate, but you need 2 coordinates. So still we shall say, if x is 5, what will y be? Y will be negative 5. So those are the 2 pairs of the points which shall use to join to be able to get this line y plus x equal to 0. After getting those points, what we need is a graph paper. Then on that graph paper, we shall draw the axes and label them. So you have to label the x-axis and also the y-axis. Then from there, we shall choose a scale for the horizontal axis or for the x-axis and feed it in. Then also choose a scale for the y-axis and also feed it in. Okay, now next is to plot this line. So we shall first use this point, negative 5, 5. So negative 5, 5, which is that. Then this point is 5, negative 5. So 5 and negative 5. So what I'm going to do, I'll get my ruler and join these 2 points using a ruler. So it has to be a straight line. So let's do that. And that becomes our mirror line. Now next we shall locate this point, which is 0, 3. And we have to get its image. So image, like I told you, you move horizontally. So 1, 2, 3, horizontally from the object to the mirror. So 1, 2, 3, 3 steps. That means that we shall also move downwards 3 units. So we shall see 1, 2, 3. So this becomes the position of the image. Therefore, we shall come and write that that is a prime. Therefore, you shall come and say that from the graph, the image is negative 3, 0. And that's what they wanted. So now we shall go to question 3, which came from UNEB 1997, paper 2, question 2, and says, determine the area of the figure enclosed by the x-axis, the line this, and the reflection of this line in the y-axis. So there we shall need the help of our graph paper. So for you to draw this line, you need to get some 2 points. So you come and say that when x is equal to 0, y will be 8. That is 1 point. And when y is 0, x will be 4. Those are 2 points. So the points are these ones, and those are the ones we shall use to draw that line. So next is to get your graph paper, draw the axes, x-axis and y-axis, and they have to be labeled. Always remember to label your axes. Then from there, get a scale for the horizontal axis or for the x-axis and feed it in. And similarly, you'll get a scale for the y-axis and also feed it in. Okay, now from there, next is to locate this point. So there's this point 0.8, which is here, and also this other point 40, which is here. Therefore, what we are going to do, we should get our ruler and join these 2 points. So when I join the 2 points, I'll come up with that, and that will be the line this. But they said that line is reflected along the y-axis. So that means that the y-axis is the mirror line. I think remember the property that a point on the mirror line does not change. So this point is not going to change, but this point will change. So this is 1, 2, 3. Let's repeat, counting. 1, 2, 3, 4. 4 units. Also we have to move 4 units away from the mirror line. So 1, 2, 3, 4. Therefore this will be the position of the image of point A. Therefore we shall come and say that point A prime is there. Therefore the image of this mirror line, of this line, will be that. So now I have formed the triangle, because they say triangle which encloses the x-axis, which is here, this line, and the image of that line. So that is a triangle, and on that triangle I can get the height and also the base. So the height is from here up to here is 8. Then from here to here is 4, from here to here is 4, that is also 8, the base. Therefore multiply, area is half base height, so when I multiply I come up with 32 square units, and that's what they wanted. Then now shall go to question 4, which came from UNEB 2016, paper 1, question 16a, and says the image of P, which is 63, after a reflection is P prime, which is 36. Roman 1, plot the points P and P prime on the graph paper. So we shall need our graph paper. Then we draw the axes and label them. Always remember to label the x-axis and also the y-axis. Then from there we shall get a scale for the x-axis and also feed it in. Do the same, get the scale for the y-axis and also feed it in. Now from there we shall locate. Remember they told us to plot points P and P prime. So P is 6, 3. Therefore come and get 6 and also 3 to get that point P. Then another point is P prime, which is 3, 6. So 3 and 6 to come up with here, which will be point P prime. Now I think you remember the property of number 2, which enables us to get the mirror line, that when you're given the object and the image, what you're going to do, you'll get your ruler and join these 2 points. Then the perpendicular bisector of that line P prime, it will become your mirror line. So what you're going to do, get your ruler and join those points to come up with that. Then from there we need to get a perpendicular bisector. Now that perpendicular bisector needs a pair of compass. So what you're going to do, get your pair of compass, put your compass needle at this point, then mark off that radius. Now that without changing the radius of that compass, put your compass needle at this point and also mark off that radius, same radius. Now next we are going to draw a line passing through these 2 points of intersection of the axis. So when you do that, you shall come up with that as our mirror line. Now next is, they said construct the line of reflection, which is this. Then next we said hence find the equation of the line of reflection. So to find the equation of a line, we need to get 2 points. So what you're going to do, we are going to get 2 points on that line. There is this point 0, 0 and also this point 1, 1. Now using those 2 points, I'll come and get the gradient as 1. I also know that the y-intercept is 0, therefore c is equal to 0. Now that I know the gradient and the y-intercept, I can come and say that the general equation of a line is y equal to mx plus c. So substitute for m and c to come up with that as the equation of the mirror line which they wanted. That was reflection using graphical approach. Now, but you can also do questions of reflection using matrices. So that takes us this part, transformation matrices of reflection. There are some matrices which you need to know of standard reflection. So they shall come and say that there are 4 common mirror lines used in reflection, and these include line x equal to 0, which is known as the y-axis, line y equal to 0, which is known as the x-axis, line y equal to x, which is, or we can also be written as this, and line y equal to negative x, which can also be written as that. Now the rest of the mirror lines will be parallel to any of the 4 mirror lines listed above. Now, in order to determine a transformation matrix in any mirror line, find the images of points 1, 0 and 0, 1 under the given reflection. Then write their respective position vectors in matrix form. So the position vector of I is written in matrix form, and becomes your first column, and the position vector of J becomes your second column. And what you get will now be the matrix of transformation for that mirror line. So let's see how that is done. For example, for the mirror line x equal to 0, which is the y-axis, we have these points I and point J. So what we are going to do, this point is on the mirror line, meaning that doesn't change. That's why J prime is at that very point. But this one changes. If this is 1, it will be on -1. That's why I prime is there. Now from there they said, write this one in column form to become that, and also this one in column form to become that. Now this one is what becomes the transformation matrix for the reflection on the y-axis, and it is that. As simple as that. So let's do the same for the rest of the line. So the line y equal to 0, which is the x-axis, do the same. This point does not change, that's why there's I prime there, but this point changes to give you this. Therefore you write it in this form, and that will be the matrix of transformation. Do the same for the line y equal to x. For the line y equal to x, this is point, okay, so this is point I. It will be reflected. To be reflected, remove this point, this distance from here to here, and so this, it will be the same distance from here to here. That will give you I prime. Now that is I prime. What about the image of J? Image of J, so we do the same. J is here, so we move from here to here, and also from here to here some distance to come up with this image of J. Then from there, write in column form. You remember you have to start with I followed by J, which gives you this matrix. And lastly, for the line y equal to -x, you still do the same. This is the object. Remove here some unit to come up with this, which is the image of I. Then also here some unit to come up with this as the image of J. The next is to write in column form to come up with this as the required matrix. So those are the 4 standard matrices of reflection. And let's see how they are used. So question 1 says, find the image of point this under the reflection in the line Roman 1 x equal to 0, y equal to 0, y equal to x, y equal to -x. So let's start with Roman 1. For Roman 1, we shall remember that the matrix of reflection for x equal to 0 is -1, 0, 0, 1. So I come and call it, then I can multiply with the object to get the image. Then after that I write the image in coordinate form. That is Roman 1. Roman 2, y equal to 0. So y equal to 0, the matrix is this, so I come and state that the matrix of reflection is that. Therefore multiply that matrix with the object to come up with the image and write it in coordinate form. The next is y equal to x. So y equal to x, this is the matrix. Therefore come and say that, recall it that the matrix of reflection is that. Therefore multiply it with the object to come up with the image and write it in coordinate form. Then lastly, for the line y equal to -x, this is the matrix. So I'll come and write it here. Then multiply it with the object to get the image and write the image in coordinate form. And that's what they wanted. So as simple as that. So that's how they use matrices of transformation to get the images of reflection. Then question 2. Question 2 came from UNEB 2007, paper 2, question 3, and says the point R, which is 10, 7, is reflected in the line y equal to x to give point S. Given that M is the midpoint of RS, find the coordinates of M. So yeah, first of all, you have to recall that the reflection of y equal to x is this. Then after that, I'll come and multiply it with this object to get the image. Therefore, the coordinates of the image is that. Therefore, point S has these coordinates. Now I have 2 points R and S, and they said M is the midpoint of RS. Now remember, the coordinates of the midpoint are got by getting the average of the x coordinates and also average of the y coordinates, which will be this, and that's what they wanted. Then question 3 came from UNEB 2007 paper 1, question 8, and says triangle ABC with vertices this underwent 2 transformations T2 T1. If T1 is a translation represented by this, and T2 is a reflection in the x-axis, find the coordinates of the final image of the triangle. So first is a translation. So for this for the image A prime, add this object to the translation to come up with this as the coordinate of A prime. Then also do the same for B. B object plus translation gives you that. Then C also object plus translation gives you that. Then for these ones, they undergo a reflection about the x-axis. So you have to remember the matrix about the x-axis, which is this. Therefore, you come here and say that the matrix of reflection in the x-axis is that. Therefore, multiply the matrix with the object to come up with the image and write them in coordinate form, and that would be the answer they wanted. So now we shall go to part 5, which is rotation. So a rotation is a transformation of an object about a fixed point, such that every point in the object turns through the same angle relative to the fixed point. A rotation is fully described by stating the angle of rotation and the center of rotation. So when they describe the rotation, it means that they want you to state the angle of rotation and also the center of rotation. So an anti-clockwise rotation will be denoted by a positive sign, and a clockwise rotation will be denoted by a negative sign. So always remember, rotation in an anti-clockwise direction is positive, and that in a clockwise direction is negative. So the question will specify whether the angle is negative or positive. When an object undergoes a rotation, the following takes place. So there are some points you need to know on the properties of rotation. So 1, all the points on the object rotate through the same angle, which is known as the angle of rotation. Then 2, only the center of rotation remains fixed. And 3, a point and its image are equidistant from the center of rotation. Point and the image are equidistant from the center of rotation, remember that. Then point 4, or property 4, is that each point on an object moves along an arc of a circle. So that means that in this topic we shall need a pair of compasses whose center is the center of rotation. And property number 5, the perpendicular bisector of a line joining the point and its image passes through the center of rotation. Property number 6, the object and its image are directly congruent. Now there's something we need to note, is that a rotation of 360 degrees is called a revolution. So they can either say 360 degrees or revolution, one revolution. Then also a rotation of 180 degrees is also given a word half turn. So when they say the word half turn, just know that the angle is 180 degrees. And when they say a quarter turn, just know that the angle is 90 degrees. So you start with part A of how to obtain the image points given the center of rotation, angle of rotation, and the object points. So if the object points, center of rotation, and angle of rotation are known, the image points can be got by following the steps below. So there are some steps which you need to follow in the very order. So let's start with step 1. Step 1 is to plot the object points and the center of rotation. So if the points are ABC of a triangle, then locate those points ABC of a triangle and also locate the center of rotation on the same graph. That is step 1. Then step 2, join the center of rotation O to point A. So if this is point A and this is point O, join this point O to the point A. Then that is step 2. Then step 3, place your protractor at the center of rotation along the object line. So this is the object line AO, so as to measure the given angle of rotation. So the given angle, it can be positive 90 degrees or negative 90 degrees or 180 degrees or any other angle. So you measure that angle. We shall see how that is done in the worked examples, but first we need to go through these steps. Then step 4, remove the protractor and then trace out the line showing the measured angle, and this will be the image line. Step 5, using a compass, place the needle of the compass at the center O and stretch its radius up to the object point A. Turn the compass without lifting it off the center and cut off the same radius along the image line. This will be the image point A prime of the object point A. And after that, we shall repeat the following steps, step 2 up to step 5, for the rest of the point, that is point B and also point C. So basically that is how they locate an image. Now let's see how it is done through this example. So example 1 says, example 1 came from UNEB 2015 paper 1 question 7, and says, part A, plot the point A, which is 4,2 on the graph. So that means that we shall need a graph paper. Then draw the axes and label them. So this is the x-axis, and also draw the y-axis and label it as y-axis. The axes have to be labeled. Next is to get a scale for the x-axis and feed it in. Then similarly get a scale for the y-axis and also feed it in. Then from there we shall plot this point A, which is 4, 2, 4 and 2, which is here. So we shall put that point there, and that will be point A. That is part A. Part B said, find the coordinates of the image of point A after a rotation of positive 90 degrees about 1, negative 1. So this is the center of rotation and this is the angle of rotation. So what we need is to first locate the center of rotation, which is 1, negative 1. Then from there they told us that to join the object, so the object here, to the center of rotation. Then from there we shall use the protractor and mark off 90 degrees. So mark off the angle of rotation, which is positive. Now positive means you go anti-clockwise. That is why this arrow is here, anti-clockwise. So from here to here it is 90 degrees using a protractor. Then from there we shall need a compass. So put the compass node here and mark off a radius of this from here to here on this object, of this image line. Then from there this intersection is what becomes your A prime. Therefore they said find the coordinates of the image. Therefore rid of these coordinates, it is negative 2, 2. Therefore you shall come here and say that from the graph A prime is negative 2, 2, and that's what they wanted. So basically that's how they locate an image point. So that has been only one point. What if there are more than one point? The same procedure, but you keep on repeating for all the points. So let's see that in this question. So question 2 came from UNEB 2009 paper 1 question 12 and says, triangle ABC with vertices A, which is 2, 1, B, which is 4, 4, C, which is 2, 4, is reflected in the line y equal to 0 to to get triangle A prime B prime C prime. Then triangle A prime B prime C prime is given a negative quarter turn. Negative quarter turn, which is negative 90 degrees. About the origin, so origin will be the center of rotation. To get the triangle A double prime, B double prime, C double prime. So part A, draw the three triangles on the same graph paper. So here there's S missing, 3 triangles on the same graph paper. So let's first draw the object. So that means that you'll need a graph paper on that graph paper. You will draw the axes and label them. So x-axis is here, and also do the same, y-axis is there. So axes have to be labeled. The next is to get the scale for the x-axis and feed it in. Then also do the same, get the scale for the y-axis and also feed it in. Then from there we shall plot points A, B and C. So point A was this, 2, 1. Point B was that, which is 4, 4. And point C was that, which is 2, 4. Then we shall join those 3 points. So we shall join point A to B, B to C, and C to A. And that will be triangle A, B, C. Now what about A prime, B prime, C prime? They told us, when we look at this, they said that this triangle A prime, B prime, C prime is due to the reflection about line y equal to 0. Line y equal to 0 is the x-axis. Therefore, we shall come here and say that, remember, y reflection is the same distance from the mirror line to the object, the same distance from the mirror line to the image. Therefore, from here to here is 1 unit, therefore from here to here it will be 1 unit, and that will be A prime. Then for B prime, do the same also. This is 1, 2, 3, 4 to the mirror, therefore from the mirror to the image it will be 1, 2, 3, 4, and that will be B prime. Then for C prime, so do the same, count 1, 2, 3, 4, 1, 2, 3, 4, and that will be C prime. The next is to join A to B, B to C, and C to A, and that will be your image. They told us to set the coordinates. So A prime is 2, -1, B prime is -4, 4, -4, and C prime is 2, -4. So now shall go to part B, Roman 2. So they told us to write these coordinates. So we have written this coordinate of A prime, B prime, C prime. What about for A double prime, B double prime, C double prime? Now to get this image, they told us that it undergoes a negative quarter turn about the origin from this. So negative quarter turn is negative 90 degrees. So that is a rotation. So we shall come here and say, first of all, locate your center of rotation, and to be here. Then from there, join the center of rotation to the object. So let's start with point A. So this now becomes the object to our image of A double prime, B double prime, C double prime. So we're going to join to this object. Then use a protractor and measure that angle of 90 degrees. So from here to here it is 90 degrees. Then from there, get your protractor, put your compass needle here, and measure off this arc radius on the image line, and that will be point A double prime. Then do the same for B prime. So B prime, join from the center to this B prime, and then use a protractor to measure 90 degrees. So from here to here it is 90 degrees. Then from there, get your compass needle, put it at the center of rotation, and mark off that distance on the image line there, and that will be B prime. Then do the same for C. Join from center of rotation to C prime, then measure off using a protractor, then get your compass needle, put it there and mark off that arc, and that will be point C double prime. Now next is to join point A to B, B to C, and C to A, and that will be the image. Therefore, you come and write the coordinates. A double prime is that, B double prime is that, and C double prime is that. Okay, so that was part B. Now we shall go to part C. Now part C says, using your graph, describe fully the transformation which maps the final image back onto the original object. So if you look at it, so they want this from here back to this. So that will be, there is some reflection. So what you need to do is to get the mirror line. So from here to here it is 1, 2, 3. Also do the same for this. From here upwards it will be 1, 2, 3. They intersect there. That is one point. Then also do the same for this point. So it is 1, 2, 3, 4, 5, 6. Also here do go upwards, it will be 1, 2, 3, 4, 5, 6. So that means that there is a reflection. So we shall join these 2 points, this and this, draw a straight line through those 2 points using a ruler. So that will be the reflection, and it will be x plus y equal to 0. Therefore, we shall come and state that the single transformation which maps the final image back onto the original object is the reflection in the line x plus y equal to 0. So that we have seen how to obtain an image given the center and angle of rotation. So sometimes they can give you the object and the image, and they want you to locate the center and angle of rotation. So that is what we are going to look at in this step. So if the object points and image points are known, the center and angle of rotation can be got by following the steps below. So step 1, plot the object points and their corresponding image points on the same graph. Then step 2, you shall start with point by point. So join point A to its image A prime to form line AA prime. Then repeat for any other point, say BB. So you just choose any 2 points, AA prime then BB prime. That is step 2. Then step 3, bisect these 2 lines formed. So bisect AA prime and BB prime. The point of intersection of these 2 perpendicular bisectors is the center of rotation. So that is how they get the center of rotation. Join object point to image point for any 2 points. Then perpendicular bisector, the intersection of those 2 perpendicular bisectors is the center of rotation. But they also need the angle of rotation. So what you need to do to measure the angle of rotation, join one of the points to the center, and that will give you the object line. Then and also join its image of that very point to the center to give you the image line. Now with an arrow, show the turn from the object to the image. So that arrow helps you to know whether it will be clockwise or anti-clockwise. So this shows that whether the turning is clockwise or anti-clockwise. And after that, we shall measure the angle using a protractor. Measure the magnitude of this angle using a protractor. So basically, those are the steps to use to get the angle and center of rotation. Now let's look at the worked examples. So question 1 came from UNEB 2017, paper 1, question 10, and says the graph below shows the line HK and its image H prime K prime after rotation in the clockwise direction. Use the graph to determine part A, the coordinates of the center of rotation, and part B, the angle of rotation. So we shall go through the same steps. The good thing here, they have already plotted for us the object and its image. So we need to go through to step 2. Step 2 said join the object point to its corresponding image point. So we shall join H to H prime and also join K to K prime. Then from there we need to get perpendicular bisectors. So that means that we need a pair of compass. So we shall get a pair of compass, put the compass needle here and draw a certain radius there. Now without changing the radius, put your compass needle here and draw the same radius there. So after that you will join this point to this point using a ruler. Draw a line through those 2 points, and that will be that perpendicular bisector of H prime. Now we are going to repeat the same procedures for KK prime. So put your compass needle here and measure off a certain radius. That. Now without changing the radius, put your compass needle here and then mark off that same radius. Then these 2 points of intersection, you are going to draw a line through them. So that will be the line, and that line will be the perpendicular bisector. So you realize that these 2 lines intersect at the origin. That means that the center of rotation is the origin, which is 0, 0. So you come and say the center of rotation is 0, 0, which you have got here. Part B, they want the angle of rotation. Now, angle of rotation, we said, join any one object point to the center of rotation. So we shall choose point H and H prime. So join from the center of rotation to the object and also to get the object line, and also from the center of rotation to the image to get the image line. Then after that you will get a protractor and measure off that angle. That angle will be 90 degrees. Now the arrow is clockwise, meaning it is negative rotation. Therefore, we shall come and conclude that the angle of rotation is negative 90 degrees. So that is how they get the center and angle of rotation. That has been for 2 points. Now let's see this one. So question 2 came from UNEB 2020, which is last year, paper 1, question 16, and says a triangle PQR has vertices these ones. PQR is mapped onto triangle P prime, Q prime, R prime, with vertices P prime, which is that, Q prime, which is that, and R prime, which is that, under a rotation. So P prime, Q prime, R prime is then mapped onto P double prime, Q double prime, R double prime after a translation of this. Find Roman 1 the center of rotation, and Roman 2 the angle of rotation. Then part B, the coordinates of P prime, Q prime, P double prime, Q double prime, and R double prime. So here they have given us the object and the image, and we need to get the center and angle of rotation. Okay, so we shall come here and say that for you to do that, you'll need a graph paper. Then on that graph paper, draw the axes and label them. Remember to label your axes, x-axis, y-axis. Then from there, get a scale for the x-axis and feed it in. Similarly, get a scale for the y-axis and feed it in. Okay, after that we are going to plot the given points. We shall plot point P, which is that 2, 1, and also point Q, which is 6, 4, and point R, which is 4, 5. Then we shall join P to Q, Q to R, and R to P, and that will be triangle PQR. We also need to locate the image, which is P prime, Q prime, R prime. So we shall come and plot point P prime, which is 10, 3, Q prime, which is 6, 0, and R prime, which is 8, -1. Then join P to Q, Q to R, R to P to get the image P prime, Q prime, R prime. So now we have object and image. We need to get the angle and center of rotation. So we shall go through the same procedure. Choose any 2 points. You can choose PQ or QR or PR. So let's start with P, join from P to P prime. Then also choose Q, join Q to Q prime. Okay. Now next is perpendicular bisectors. Get your compass needle, put it at P, then mark off any radius, which is that. Without changing the radius, put your compass needle at P prime and mark off the same radius. Then draw a line through these points of intersection using a ruler. Okay, do the same for Q. So put your compass needle at Q, mark off any radius. Without changing that radius, put your compass needle at Q prime and mark off the same radius. Then draw a line through these 2 points of intersection. Okay. Now these 2 lines, this one and this one, intersect at this point. So that point of intersection is what becomes the center of rotation. So you can say that Roman 1 center of rotation is 6, 2. Okay, now we have got the center of rotation. We have to also get the angle. The angle, we join the object to the center of rotation and also image to the center of rotation, and that angle will be 180 degrees. And the rotation is clockwise, meaning it is negative. Now part B. Part B, they talked about its translation. Part B, the side is given this translation. So what we need to know, you can either show it graphically or just use calculations since they didn't specify. So just that for P prime, add the translation to P. So for P double prime, add translation to this P prime to come up with that. Then for Q double prime, add translation to Q prime to come up with that. And for R double prime, add translation to R prime to get this, and that will be the answer they wanted. So now shall go to question 3. Question 3 came from UNEB 2014, paper 1, question 15, and says a triangle with vertices A, B, and C is mapped onto triangle A prime, B prime, C prime by a translation this. Triangle A prime, B prime, C prime is then rotated through positive 90 degrees about 0.32 to triangle A double prime, B double prime, C double prime. Part A. Plot the point A, B, and C on a graph paper. Join the points to form triangle ABC. So let's first do that. So we shall need a graph paper. Then on that graph paper we shall draw axes and label them. So label this x-axis and also draw the y-axis and label it as y-axis. Then choose a scale for the x-axis and feed it in. Do the same, choose a scale for the y-axis and feed it in. Then from there we are going to plot. So plot point A, which is -1, 1, point B, which is -1, 3, and point C, which is -2, 3. Then join A to B, B to C, and C to A to get triangle ABC. So that has been part A. What about part B? Part B, they want you to find the coordinates of A prime, B prime, C prime. That was under a translation of this, of 2, 1. Therefore, we shall come here and say that. Now, in the previous question, we saw how to get the images using calculation method. Now, we're going to see how to use graphical method. So here it means that 2, 1 means that you move 2 steps horizontally and 1 step vertically. Positive 2 means you move to the right 1. Remember, 2 two big squares represent 1, so this is 1, 2. That is 2 units horizontally, then 1 unit vertically to get this. So that will be the position of A prime. Then do the same for B. Move 2 steps, 1, 2, and 1 step vertically, and that will be the position of B prime. Then do the same for C. Move 2 steps, 1, 2, and 1 here, that will be the position of C prime. Then join A prime B to B prime prime to C prime, and C prime to A prime to get triangle A prime BC B prime C prime. Therefore the coordinates A prime is that, B prime is that, and C prime is that. That was B Roman 1. What about B Roman 2? So B Roman 2, they want coordinates of A prime, A double prime, B double prime, and C double prime. Now those ones were got by rotation of positive 90 degrees about 0.32 as the center. So you come here and locate the center of rotation. The center is 32, which is here. So I'll join this point. Now this is the image, so join the center to the object, then use the protractor to mark off 90 degrees in an anti-clockwise because they said positive. So from here to here it is 90 degrees. Then use the protractor, get a pair of compass, put your compass under here and measure, mark off this radius on the image line, and this will be the point A prime, A double prime. Do the same for B prime. Join, then measure, use the protractor to measure 90 degrees, then get your pair of compass, put it there and mark off that arc, and that will be B double prime. For C prime, join from center to C prime, measure off 90 degrees, and then use a pair of compass, put the compass under there and mark off that arc. So next is to join the 3 points. So join the 3 points to get that triangle. Therefore you come and say that A prime is that, B prime is that, B double prime is that, and C double prime is that. So that was part B. Now shall go to part C. Part C says, find the center and angle of rotation which maps the final image back onto the original object. So that means that we are interested in this and this. So you go through the same procedure. Join, if I choose A, join A to A double prime. Then so join B double prime to B. Then get perpendicular bisectors. So perpendicular bisectors is that, there is that. And there is also that. So we put a compass under here, draw that arc, and also here draw that arc. Then join these 2 points using a ruler. That will be perpendicular bisector for A prime. What about for B prime? So put your compass under here, draw that arc. Then also put your compass under here, draw that arc. Then join these 2 points, and that will be a perpendicular bisector. So the intersection of these 2 perpendicular bisectors is here, and that will be the center of rotation. Then the angle of rotation we join. So the center of rotation is 1.5, 2.5. Then the angle of rotation, you are going to join this center of rotation to point B double prime, and also this center of rotation to point B here. Then use a protractor and measure off that angle, and to be 90 degrees. So it is clockwise, meaning it will be negative. Therefore you come and conclude that the angle of rotation is negative 90 degrees. So now if you have seen graphical method for rotation, now we shall go to the method of using transformation matrices. So there are 4 common angles of rotation, as you already seen, and these include positive quarter turn, negative quarter turn, positive half turn, and negative half turn. So in order to determine the transformation matrix, it is the same procedure as we did for refraction. We find images of points I and J under the given rotation, and then write their respective position vectors in matrix form. So let's see how that is done. So for positive quarter turn, this is a point I and this is point J. Positive quarter turn means anti-clockwise. So from here, 90 degrees is from here up to here. That is why there is A prime here. And for this object, negative anti-clockwise is that, and that will be the image for J. Therefore, write I prime J prime in matrix form, and that will be the matrix they want. Then for negative quarter turn, for this object here, image will be there, and for this object, image will be here. So write in matrix form, and that will be the matrix of transformation. For positive half turn, from the object, if this is the object, 180 degrees is here. Then if for this object, 180 degrees is here. So write those objects and to give you the matrix. For negative half turn, for this object, 180 degrees there. For this one, 180 degrees is there. So it gives you these objects, and that will be the matrix. So now, without using that graphical approach, we can use the general matrix of transformation. So here, if the angle of rotation is known, then the matrix of transformation can be got using this formula, that cos theta, negative sin theta, cos theta. For example, the matrix for positive quarter turn, theta is 90 degrees. Therefore, put 90 degrees where there is theta, you'll be able to come up with this matrix. Similarly, for negative quarter turn, angle is negative 90, you come up with this. For positive half turn, angle will be positive 180 to come up with this. And for negative half turn, angle will be negative 80 to come up with this. Now, there's something we need to note is that both the negative and positive half turn have the same matrix. That means that there is no need for the question to specify whether the half turn is positive or negative. They will just say half turn. So it is up to you to either choose negative 180 or positive 180. But for quarter turn, they have to specify whether it is positive or negative, since these two are different. So with that, we shall go through some of the questions. Question 1 says, the endpoints of line AB, whose coordinates are this and this, undergo a rotational transformation about the origin to give the image this. Find the coordinates of A prime and B prime if the transformation is a positive quarter turn, a negative quarter turn, and a half turn. So what I didn't tell you, the general method works only when the center of rotation is 0, 0, just as it was for graphical part. So we shall start with Roman 1. Roman 1, we have to remember the matrix for positive quarter turn is this. Therefore, we shall come here and multiply. First recall the matrix, then multiply the matrix with the object to come up with that. Therefore, the A prime is that and B prime is that. What about for the negative quarter turn? Negative quarter turn, still matrix is that. Therefore, multiply that matrix with the object to come up with the image. Write in coordinate form, and that will be the answer they wanted. Then for half turn, matrix is that. Therefore, multiply that matrix with the object to come up with the image. Write in coordinate form, and that is the answer they wanted. Then question 2 says, came from UNEB 1997, paper 1, question 10, and says, given that H denotes half turn above the origin and X denotes refraction in the x-axis, find a single transformation to XH on the points of the unit square. So yeah, the transformation matrix XH means that first becomes last and last becomes first. So the same as X for H followed by X. Therefore, you come and draw our unit square, draw the axes, label them. Then put there the unit points: -1, +1, -1, +1. Then we shall locate the objects I, which is 1, 0, and j, which is 0, 1. Now h is half turn, so let's make it positive. So whether you make it positive or negative, you still get the same, you still reach at the same point. So if I rotate this one 180 degrees, I'll come up with this as my I prime. Then using this point, I also rotate 180 degrees to come up with this as my j prime. That is x. What about h? Sorry, h. What about x? X denotes reflection in the x-axis, so this is the mirror line. That means that the image of I prime, remember I prime is on the mirror line, therefore this image is at that very point. That is why there is I double prime here. Then by this j prime, the image will be here, so we shall put j double prime here. After that, we shall write a single matrix, and a single matrix will be for I double prime, j double prime, which is that, and that's what they wanted. So we are concluded that single matrix is a reflection about the y-axis. So that has been rotation. Now we shall go to enlargement, which is the last part. So enlargement, this is a transformation which changes the size and position but not the shape of the object. Thus the object and this image are similar. Two figures are similar. What do they mean by similar? So two figures similar if their corresponding lengths are in a constant ratio and they are equiangular, the angles are the same. Angle on the image and are equal to angle on corresponding angles on the object. Enlargement is fully described by stating the center of enlargement and the enlargement scale factor, or known as the linear scale factor. An enlargement scale factor can be negative or positive. So a scale factor is defined as a scalar quantity which, when operated on an object, can either increase or decrease its size. In simple terms, a scale factor is a factor by which the size of a given object changes and is given by the formula. So there's a formula we use to get the scale factor, and the formula is scale factor, which is denoted by k, is equal to the length of side of the image over length of any side of the object. So we choose one side, it can be side AB, so you choose A prime, B prime to become the length of the side of the image, and also side of the object will be AB. So similarly, there is what we call area scale factor. So this one is the square of the linear scale factor, and is the ratio of area of the image to area of the object. There are some things we need to note here before we go through the works examples. So one is that the center of enlargement, the object point, and its corresponding image are collinear, so they lie on a straight line. Then if k, which is the scale factor, is positive, that's what they mean by greater than 0, the object and its image are on the same side of the center of enlargement. So if this is the center of enlargement, object will be here and image will be here. But if the scale factor is negative, the object and image are on opposite sides. So if this is the center of enlargement, object will be here and image will be this side, opposite sides. If the scale factor is between 0 and 1, then the image is smaller than the object. But if it is equal to plus or minus 1, then the object and its image are congruent. So with that, let's go through these parts. So we shall break it down in two parts. So the first part is center of enlargement for a positive scale factor. How to calculate center of enlargement for a positive scale factor. So here we shall see that if the scale factor is positive, it implies that the object P and its image P prime are on the same side of the center of enlargement C, as shown below. So this is the center of enlargement, this is the object, and this is the image. Therefore, center of enlargement C is thus calculated from the formula that distance from the center to the image is equal to scale factor multiplied by the distance from the center to the object. Remember that scale factor is ratio of length of image to length of object. So this is like length of image over length of object equal to scale factor. Therefore, length of image, that means that length of image will be equal to scale factor times length of object. And that's where this formula is coming from. So with that, let's look at some of the questions. Question 1 came from UNEB 2006, paper 2, question 8, and says, under the enlargement of scale factor 3, when they just say scale factor, it is automatic that it is linear scale factor. So under the enlargement of scale factor 3, the image of the point P, which is 0,3, is P prime, which is 4,5. Find the coordinates of the center of enlargement. So first of all, the scale factor is positive, meaning that the arrangement will be in this form. Object, image, center. Therefore, length of the image is equal to scale factor times length of object. Therefore, in vector form, this one is the same as OP prime minus OC, and vector form, this is OP minus OC. Then we shall substitute for our aim is to make OC the subject. So when I open brackets, I'll come up with this. Then put OC on one side to come up with that. So this is OP, this is OP prime, OP, but I want to make OC the subject. So bring this on this side and this on this side to come up with that. My aim is to make OC the subject, therefore OC will be that. But in coordinate form, it will be that, and that will be the center of enlargement. Then question 2 came from UNEB 1999, paper 2, question 4, and says, under an enlargement of scale factor 3, the image of this is this. Find the coordinates of the center of enlargement. Still, we shall do the same. Make our simple sketch, and to be that. Then we shall see that length of image is equal to scale factor times length of object, and that will, expanding this gives you that, this gives you that. Open brackets, you come up with that. Substitute for OP prime and OP, then make OC the subject, and that will be that. Therefore, the center, coordinates of the center will be this. Then question 3 came from UNEB 1993, paper 1, question 8, and says, the image of this under an enlargement scale factor 3 is this. Determine the center of enlargement. So still we shall do the same, make a simple sketch. Then we shall say distance of image is equal to scale factor times distance of object. Expand this to give you that, this to give you that, open brackets to give you that, then substitute for OP prime and OP to give you that, then make OC the subject, you'll come up with that. Therefore, the coordinates are those ones. Then now shall go to part B, which says center of enlargement for negative scale factor. So if the scale factor is negative, it implies the object P and this image are on opposite sides of the center of enlargement. Therefore, when we make a sketch, this will be the center of enlargement, object will be here, and image will be this side. So that what we do, which is that enlargement, the center of C can be calculated using the formula that this P prime from here to here is equal to the scale factor, but the scale factor will be magnitude. Magnitude of the scale factor of from here to here. Magnitude means that what is negative, the negative is ignored. Therefore, question 1 came from UNEB 1998, paper 1, question 4, and it says the image of the point this under an enlargement of scale factor this is negative is this. find the coordinates of the center of enlargement. So here we shall make our sketch such that the center of enlargement is between the object and the image. Therefore, P prime C is equal to scale factor times magnitude of scale factor times CP. So the order matters, it has to be in the same direction. Then expand that, open brackets, substitute for O prime, OP and OP prime, then make OC the subject. So if I make OC the subject, I'll come up with that. Therefore, in coordinate form, that will be the center of enlargement. So note that we used magnitude here and not the order of the displacements. Then part C, obtaining image points for positive scale factor. So if the object points, center of enlargement and scale factor are known, the image points can be got by following the steps below. So step 1, plot the object points and the center of enlargement O on the same graph. Then step 2, join the center of enlargement O to point A and extend the line further away from A. Step 3, locate the image point A prime such that the distance OA prime is equal to K, which is the scale factor, times OA, which is the object distance, where K is the given scale factor. Step 4, repeat step 2 and step 3 for all the other points. So let's see how that is done graphically. So question 1 came from UNEB 2006, paper 1, question 12, and says, part A, Roman 1, plot on a graph the triangle ABC whose vertices are this. So let's start with a Roman 1. So we shall need a graph paper, then we draw the axes, x-axis and y-axis, and label them. Then we shall choose a scale for the x-axis and feed it in. After that, we shall choose a scale for the y-axis and also feed it in. Then we shall plot the points. So that is point A, which is 1, 1, point B, which is 3, 2, point C, which is 2, 4. Then join A to B, B to C, and C to A. That would be triangle ABC, and that was Roman 1. Then Roman 2 said, on the same graph paper, enlarge triangle ABC using -1, -1 as the center of enlargement and a scale factor of +2 to obtain its image A prime, B prime, C prime. So first we shall locate our center of enlargement, which is -1, 1 here. Then next we shall join this center of enlargement to point A and extend it further. Now how do we locate A prime? Remember the scale factor was 2, meaning that it will be twice the object distance. So from O to A, that is 1. Okay, let's use the horizontal and vertical. If I use the horizontal and vertical from O to A, it will be 1, 2. Those are 2 units, meaning that 2 units times the scale factor, which is 2, it will be 2 times 2, which is 4. Therefore, I have to locate A prime, I have to move 4 units horizontally. Therefore, I'll come here and say that this is 1, 2, 3, 4. When I reach here, I'll just take upwards to meet this line which I've drawn, and that will be the position of A prime. Then do the same for B. Draw a line and extend it further. Now from here to OB to be 1, 2, 3, 4. That is 4. Now 4 times 2 is 8. Therefore I have to move another 4 points 1, 2, 3, 4 to make the 8. Therefore, vertically it means that this will be the point of B prime. Do the same for C. So I'll count 1, 2, 3. That is 3. It means that I have to move another 3 points. 1, 2, 3. So intersection will be, that will be our point C prime. So that is how they locate the images in enlargement, as long as the scale factor is positive. The next is to join those 3 points to come up with the triangle A prime, B prime, C prime. Then for Roman 3 they said, state the coordinates of A prime, B prime, C prime. So we shall come here and state that A prime is that, B prime is that, C prime is that. Okay, so now we shall go to part B. So part B says, using your graph, find the area of the triangle ABC and hence determine the area of triangle A prime, B prime, C prime. So you shall first use the graph to find the area of triangle ABC. Now, triangle can be got in 2 ways, but let's look at the simpler one. Simpler one is by counting the squares. So squares, I'll come and divide my triangle here. If I look at this one is half of this rectangle. Therefore, this rectangle, the area is 2 units. Therefore, this one alone will be 1 unit. So I'll come and say that that is 1 unit. Then when I look at this from here to here, that rectangle is 2, meaning that half of it is 1 unit. But remember, there is this part which is not included on our triangle. Therefore, this part, I'll come and this part has been brought here. So when I join this, so when I join this to this, I'll be able to get my complete 1 unit, and therefore I'll come here and say that that with that is 1 unit. Now what I'm left with is this. Now this one is half of the whole of this 1 unit, therefore it will be 0.5. So I'll come here and say that this is 0.5. After getting that, I will come and conclude that area of triangle ABC is 1 plus 1, this one plus this one plus this 0.5 to give you 2.5 square units. Then now for the hence part, I'll use now the area scale factor is equal to area of image over area of object. Now area scale factor was 2, but that 2 is linear, therefore area scale factor is squared. Area of image over area of object, which we have got here. So when I make area of image the subject, it will be 10 square units, and that's what they wanted. Then now what we have seen how to obtain image points for positive scale factor. What if the scale factor was negative? So if the object point, center of enlargement, and scale factor are known, the image points can be got using the steps below, as long as the scale factor is negative. The first step is the same as before. Plot the object points and also the center of enlargement on the same graph. Then step 2, join A to the center of enlargement and extend the line further away from O. Previously we extended the line further away from A, now we are extending it further away from O. Why? Because the center of enlargement is in between the object and the image. Then step 3, locate the image point A prime such that OA prime is equal to magnitude of the scale factor, meaning that the negative will be ignored, multiplied by the distance OA, where this is the magnitude of the scale factor. There I will be able to locate point A prime. So I'll do the same to locate these other points of B prime and C prime. So let's see how that is done graphically. So question 1 came from UNEB 2013 paper 1 question 17 and says triangle ABC with vertices these ones is enlarged with scale factor of -4 about 2, 2 as the center to triangle A prime, B prime, C prime. Then this triangle A prime, B prime, C prime is then rotated through a positive quarter turn about this 0, -4 as the center to triangle A double prime, B double prime, C double prime. Then part A, draw on the same axis the triangles ABC, A prime, B prime, C prime, and A double prime, B double prime, C double prime. So let's first do that. Then part B, they want you to state their coordinates. So yeah, first you should need a graph paper. So you get the graph paper, then draw the axes and label them. So you draw the x-axis, label it, draw the y-axis, and also label it. Then get a scale for the x-axis and feed it in. Also get a scale for the y-axis and feed it in. Okay, then next is to plot. So we are given points, the object points. So A is that 1, 3, B is that 3, 3, and C is that 3, 1. So we shall join those points A to B, B to C, and C to A to get triangle ABC. Okay. Then what about A prime, B prime, C prime? So for that one they said it is enlarged with a negative scale factor. Negative means the center is in between the object and the image, about this center. So we shall first locate the center to 2. So center 2 is there. Now what we need to do is to join point A to this point O and extend it further. So let's do that. Now how do we know where to stop? To know where to stop, you should count. So from here to the object is just 1 unit. You can see horizontal is 1 unit, meaning that 1 multiplied by 4 is 4 units. Therefore from this center of the image it will be 4. So come and say 1, 2, 3, 4. So this line, the intersection is this. So that's how you can locate point A prime. Do the same for B. So for B, I'll join B to O, then I'll count. From here to here it is 1, therefore from here to be 1 times 4, which is 4. So 1, 2, 3, 4. So this line will meet at B prime. Then do the same for C. So for C, I'll come and draw C to O to come up with that. So from here to here it is 1, therefore here to be 1, 2, 3, 4. That gives you your point C. Now I have to join those 3 points to come up with a triangle of the image, first image. And that is our first image, A prime, B prime, C prime. So now we also need to get A double prime, B double prime, and C double prime. Let's look at the information about that. So here they said this is then rotated through positive quarter turn about the center 0, -4 to triangle this. So we shall come and locate the center of rotation. Center of rotation is this 0, -4, and it is positive quarter turn. So I'll join that center to the object. This is now the object. So then use the protractor to measure off 90 degrees. Draw that line. Then use a compass. Put your compass needle here. Measure off this radius up to the image line, and that will be A double prime. Do the same for B. Join that point to B prime. Then use the protractor to measure off 90 degrees. Then use the compass. Put the compass needle there and draw that arc, and that will be B double prime. Do the same for C. Join to C prime. Then measure off 90 degrees using a protractor. Then put a compass needle there and draw that arc, and that will be point C double prime. So next is to join those 3 points to come up with a triangle they want. Then we come on to part B. They wanted you to state the coordinates. A prime is that, B prime is that, C prime is that. Then for Roman 2, they wanted to state the coordinates. A double prime is that, B double prime is that, and C double prime is that, and basically that is what they wanted. Then part E is obtaining center of enlargement and scale factor. So if the object points and image points are known, then the center of enlargement and scale factor can be got following the steps below. So the first step is to plot the object points and image points on the same graph. Then step 2, join point A to A prime. So join image object point to its corresponding image point to get that line. Then repeat for any other one line, so let's say B prime. Then step 3, if the two lines intersect between the object and its image, the scale factor will be negative, and the point of intersection is the center of enlargement. The scale factor is calculated from the formula that scale factor is equal to length of side of image to length of side of object, but remember there has to be a negative here. That is if the intersection is in between the object and image. But what if it is not? So if the two lines intersect further away from the object, the scale factor will be positive. Therefore the point of intersection is the center of enlargement, and the scale factor is calculated from this same formula, only that this is now positive. Okay, so with that we shall go through some of the questions. So question 1 came from UNEB 2012 paper 1 question 9, and says the diagram below, triangle PQR is mapped onto P prime Q prime R prime by an enlargement. Use that diagram to find the coordinates of the center of enlargement and the enlargement scale factor. Now the good thing, they have already drawn for us the object and the image, so step 1 is already catered for. What we shall do, we shall start from step 2, where we join any two corresponding points with their corresponding images. So let's choose point Q with this image Q prime, and also point R with this image R prime. So they intersect at this point. What does that mean? It means that the point of intersection is the center of enlargement. Therefore, we shall come and state that the center of enlargement is 0, 3. That is part A. What about part B? They want the scale factor. Scale factor, because the center of enlargement is in between the object and image, you must put the negative there. Then length of the image side over length of object side. Now QR, we shall count 1, 2, 3, 4, 5, 6. That is why you put 6 there. Then for this one, we shall count 1, 2, 3. That's why you put 3 there. So in the end, we shall come up with -2 as the scale factor. So that is how they get center of enlargement and scale factor. Question 2 came from UNEB 1997 paper 2 question 6, and says in the graph A prime B prime C prime is the image of ABC under an enlargement of scale factor F. Determine the value of F, which is the scale factor, and Roman 2, the coordinates of the center of enlargement. So the scale factor will be that. Why? Because the center, when we join, for example, if I join this to this and this to this, the center will be in between. That is why there is a negative here. Then BC, B prime C prime, it is 1, 2, 3. That's why you see 3 here. Then also here it is 1. It is 1, 2, 3. That's why you see 3 there. So in the end, you shall come up with -1 as the scale factor. Then Roman 2, they want the coordinates of the center of enlargement. Therefore, we shall come and join these 2 points, that and that. And the center of enlargement will be this. So we shall come and state that center of enlargement is 4, 5. And that's what they wanted. Then now we shall go to transformation matrix for enlargement. We shall say that if the center of enlargement is 0, 0 and the scale factor is K, then the matrix of enlargement is K0, 0, K. Otherwise, the matrix of enlargement is got by calculations. So that we will go through these questions. Question 1 came from UNEB 2012, paper 1, question 6, and says a triangle ABC has vertices A that, B that, and C that. Its image under a transformation matrix M has vertices those ones. Part A. Find matrix M and describe fully the transformation. So let's start with Roman with part A. So shall let M the matrix be A, B, C, D. So that matrix multiplied with this object gives you this image. So you multiply matrix multiplication gives you that. Then when I equate, simplify, come up with that, then I will start equating. So this with this gives you that, therefore A is 2. Then this with this gives you that, therefore B is 0. This with this gives you that. Sorry, this with this gives you that, therefore C is 0. And lastly, this with this gives you that, therefore D is 2. Therefore, transformation matrix will be 2, 0, 0, 2. Now, this one is in the form K0, 0K, therefore it is an enlargement matrix. So, you shall come and say that the matrix of transformation represents an enlargement with linear scale factor 2 and center of enlargement 0, 0. Then part B said the triangle A prime, B prime, C prime is then transformed by matrix N, which is 0, 1, 1, 0, to triangle A double prime, B double prime, C double prime. Find the coordinates of A double prime, B double prime, and C double prime. So this one with this image will come up with that. Therefore A double prime is that, B double prime is that, and C double prime is that. Then part C, determine a single transformation matrix which would map the image, final image, back onto the original object. So that means that there should be an inverse somewhere. So you come and say that the single matrix of transformation which would map this back onto this is the inverse of NM. So I'll come and first get NM, which is that, then get the determinant, which is that, and therefore the adjoint is that. Therefore the single matrix is the inverse, which is 1 over determinant times the adjoint, which gives you that. And that's what they wanted. Then question 2 came from UNEB 2010, paper 1, question 13, and says a triangle with vertices this undergoes 2 successive transformations P1 and P2. The transformation P1 is represented by this and P2 by this. Part A, find the coordinates of the vertices A prime, B prime, C prime, which is the image of ABC under P1. Then Roman 2, vertices A prime, B prime, A double prime, B double prime, C double prime, which is the image of A prime, B prime, C prime under transformation matrix P2. So this multiplied by this object gives you this, therefore these are the coordinates A prime, B prime, C prime. Then for Roman 2, this P2 multiplied by this here will give you this, and therefore the images will be A double prime, B double prime, C double prime. Then part B says, show on the same axis the 3 triangles ABC, A prime, B prime, C prime, and A double prime, B double prime, C double prime. So you need a graph paper. So you come here and say that for part B we shall get a graph paper, then draw the axes and label them x-axis and y-axis. Then get a scale for the x-axis and feed it in. Similarly, get a scale for the y-axis and feed it in. Then we shall start with the triangle ABC. So A is that 2, 4, B is there 6, 4, C is there 1, 6. So we shall join AB to BC and CA to get triangle ABC. Then also plot A prime there, which is negative 4, 2, B prime, which is negative 4, 6, and C prime, which is negative 6, 1. Then join the points to get the triangle that. So next we shall plot A double prime, which is negative 2, 1, B double prime, which is negative 2, 3, and C double prime, which is negative 3, 0.5. Then we shall join the points to get that triangle. So that was part B. What about part C? So part C, they said use your graph in B above to describe fully the transformation represented by P1 and also P2. So shall come and join point A to A prime and also point B to B prime. The next is to bisect. So put your compass needle here at A, measure a certain radius that. Then without changing the radius, put your compass needle at A prime, make that arc. Then draw a line through those points of intersection. Do the same for B, B prime. So put your compass needle at B, measure off a certain radius, put the compass needle at B prime without changing the radius, and make that arc. Then join the points, 2 points of intersection to come up with that. So you realize that they intersect at this origin, meaning that the center is 0, 0. So you come and join this center of enlargement to this object and also to the image. Then measure off that angle and to be positive 90 degrees. Therefore, for P1 is a transformation matrix of positive quarter turn about the origin. What about P2? P2 is from this to this. So realize that they say the shape has decreased in size, meaning that it's under enlargement. So what we shall do, we shall join A to A prime to A double prime, B prime to B double prime is already there. Then also join C prime to C double prime. They all intersect at this origin. So the center of enlargement is 0, 0. Now the scale factor is what we need. So the transformation from this to this is an enlargement about the origin, but we also need the scale factor. So scale factor will be this from here tier, which is 2 units, and from here tier, which is 4 units. So 2 over 4 is a half. Therefore the scale factor is a half. That means that P2 is a transformation matrix of enlargement with linear scale factor half about the origin. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be for senior 2 and to be on the topic of indices. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on indices has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.